Today I will be recording several videos to prepare you for your next test. The first video I'm going to do is 2008 Form B question 5. Right, it says let g be a continuous function with g of 2 equals 5. The graph of the piecewise linear function g prime, which is the derivative of g, is shown to the right for negative 3 is less than or equal to x, which is less than or equal to 7. Part A says find the x-coordinate of all points of inflection of the graph of g of x between negative 3 and 7, the open interval. Justify your answer. All right, so whenever you hear points of inflection, the first thing that should come to mind is our second derivative number line that we always did in class. So when I'm talking about points of inflection of g, I want to look at g double prime. Okay, but when I look at my original graph, I notice that this is the graph of g prime. So you need to think to yourself, how does g double prime relate to g prime? So g double prime is the slope of g prime. So I want to look at the slope of g prime, and that is going to give me g double prime. So when I look at my graph, I have an increasing line, so a positive slope, a negative slope, and then a positive slope. Okay, so that's going to be important to us. Okay. So I was positive until I got to 1, and then I was negative. And there is actually kind of a critical value in negative 1 too. So it's positive, positive, and then it's negative until you get to x equals 4. So these are all x values that I'm putting at the bottom. And then it's positive again after 4. All right, so what that means is that we had concave up, concave up, concave down, concave up. So we need to decide if we have a point of inflection in certain places. So I know for sure that I have points of inflection at 1 and 4 because I changed in concavity. My g, so all you need to write for those is you say points of inflection x equals 1 because, and you write like g double prime goes from, and you can write plus for positive, so it went from positive to negative, and at x equals 4 because g double prime goes from negative to positive. You could also say switches sign. Okay, but then you also probably need to think about what's happening at negative 1. Okay, so at negative 1, if you notice, when we talk about a point of inflection, that's going to be when g double prime is equal to 0. So the question is, does g double prime equal 0 here? All right, the slope of g prime is not equal to 0 there. The slope was, you can count. I mean, you could do rise over run. So it's 4 over 2. So the slope is 2 here. And then the slope is up 1 over 2. It's 1/2 here. Okay, so what that means is at negative 1, the slope was undefined. So it's not equal to 0. Your slope from the right and left had to be exactly the same thing. So there is no point of inflection at negative 1. All right, part B. Part B says find the absolute maximum value of g on the interval negative 3 to 7. Justify your answer. Okay, all right, so we have actually learned about antiderivatives, but very, very briefly in class, so we haven't talked much about them. So what I would ask on your test is I would say find the location. So find the location of the local max, and I would make it on the open interval negative 3 to 7. Because if you remember when we talked about maximums in class, we said if I have a closed interval, I need to check the endpoints as well. Now, if I say find the maximum value, that's always talking about the y value. But right now, we are unable to find the y value with our limited knowledge on antiderivatives. So we're not going to do that on this first test. All right, so we need to find the location of the local max. So let's think. For part B, when I hear local max, I think of my chart. Now, once again, I just want to remind you that this chart is not actually graded on the AP test. They won't even look at it, so you always need to write what happened. So that's like we did right here. We wrote what happened in the chart. So make sure you're not just doing the chart for your justification. All right, so G prime. So G prime is actually given to us in the graph. So G prime was below the axis, so it's negative. Then it was above the axis, so it's positive. Still above, below the axis, and then above the, or wait, below the axis, and then above the axis. Okay, so our points of interest are -1, 2, and 6. These are the locations where we change from negative, then to positive, then to negative, then to positive. All right, so I have -1, 2, and did I say 6? 2, 3, 4, 5, 6, yes. Okay, so it was negative, and then it was positive until 2, then it was below the axis, so negative, and then it was positive again. Okay, so what this chart tells us is that we're decreasing, then increasing, then decreasing, then increasing on g of x. Okay, so if I was decreasing and then increasing, there's a local min here. There's a local max here, a min. And then the endpoints, so at -3 and 7, we're talking about the open interval. So on your test, I would only talk about the open interval. Okay, so there is a local max at x equals 2. So like I said, we can't actually find g of 2 yet with our limited knowledge of antiderivatives. So local max at x equals 2. And then you'd have to write because, so it says justify your answer. So you'd say because g prime is positive on -1 to 2 and negative on 2 to 6. And that would be enough justification. Now be very careful with your terminology. You always want to be very specific. So you don't want to say like the graph is positive and then the graph is negative. You want to talk about the particular function. And then you also have to be really careful. I said g prime is positive. I could also say g, so the original g of x function, which we do not have in our graph. So you could say g is increasing on -1 to 2, and g is decreasing on 2 to 6. So you could state it that way as well. All right, C. So it says find the average rate of change of g of x on the interval -3 to 7. Okay, so average rate of change, we learned that really early on in the year. So average rate of change for g of x, I usually write ARC, is g of 7 minus g of 3 all over 7 minus 3. Okay, we actually don't know what those are, so I guess I couldn't ask part C either, because we do not actually have the g. If I asked, I might ask what's the average rate of change of g prime. I could do that. So the average rate of change of g prime would be this. And we could do that based on our graph, so we already have g prime. Okay, so g prime of 7, that's this point here, so that was 7 comma 1, so it's 1, minus g prime of 3, so that would be right here. Now you can find what that is, because this is just a line segment. It has slope. You go down a certain amount and over a certain amount. So your slope is down 3, right 1, 2, 3. So you should just go down 1, right 1, down 1, right 1. So that point is negative, or wait, 1, 2, 3, 3, negative 1. All right, so g prime of 3 would be -1 all over 7 minus 3. So it's 1 plus 1, so 2, over 4, which is 1/2. So like I said, that would be if I asked the average rate of change of g prime. If I asked for the average rate of change of g of x, you would need to find the antiderivative at 7 and -3. Okay, D, so find the average rate of change of g prime of x on the interval -3 to 7. Okay, so we just did that, so that's actually part D. Do that, have that. Does the mean value theorem applied on the interval -3 to 7 guarantee a value of c, where c is between -3 and 7, such that g, what does that say? G double prime of c is equal to this average rate of change. Why or why not? Okay, so let's think about that. Okay, our mean value theorem, if you remember, we need for our function to be continuous. So this is for g prime, and g prime is continuous. Is g prime differentiable? Notice when you look at your function, so our original function g prime, our graph, I guess, it is not differentiable everywhere. And the reason it's not differentiable is because we have these corners. So functions are not differentiable at corners and cusps, or where it's undefined. Basically, where our left-hand derivative is not equal to our right-hand derivative, we're not going to be differentiable. So say not differentiable on the open interval -3 to 7. So no, the mean value theorem would not guarantee that. All right, so that's the end of that question. Let's go to the next question. Okay, I'm going to go ahead and skip to one of the later ones. Okay, let's do 1999 AB, so the AB exam number 4. So let's go to 1999 AB 4. Okay, so this says, suppose that the function f has a continuous second derivative for all x, and that f of 0 equals 2, f prime of 0 equals -3, and f double prime of 0 equals 0. Let g be a function whose derivative is given by g prime of x equals e to the -2x times the quantity of 3f of x plus 2f prime of x for all x values. So part A says, write an equation of the tangent line to the graph of f at the point where x is equal to 0. All right, so the tangent line. So you should know how to do tangent line problems. So tangent line to the graph of f. So that means you need to find f prime of 0. That's going to be your slope. Well, you were given f prime of 0 is equal to -3. You also need to know the point on the f function at x equals 0. So the point, if you notice, when you plug in 0 into f, you get 2, because we knew f of 0 was equal to 2. So my point is 2. So that means that I have y minus 2 equals m, so -3, times x minus 0. You can leave your answer like that, and we actually recommend that you do, so that you don't make any errors in your simplification. Okay. Part B. So is there sufficient information to determine whether or not the graph of f has a point of inflection when x is equal to 0? Explain your answer. All right, so in order to know if there's a point of inflection, we need to know if we change sign. So if f double prime went from positive to negative or from negative to positive. All right, so when I look at f double prime, I know that I have f double prime of 0 equals 0. But we don't know if it changes sign. So that means we cannot determine if there's a point of inflection. Okay, and that is very confusing for a lot of people because they think if f double prime is equal to 0, there's automatically a point of inflection there. But here's an example. Think of y equals x to the 4th. Okay, y prime is 4x cubed. Y double prime is 12x squared. That means at x equals 0, y double prime is equal to 0. But if you think about the graph of x to the fourth, it kind of looks like x squared, except it looks a little bit more flattened out at the bottom. So it looks like that. There's only one point that's really of significance. So at 0, that's a minimum, but it was always concave up. So I never changed in concavity, therefore there's no point of inflection there. So that's an example you can think of when you get confused on point of inflections. Okay, C. Given that g of 0 equals 4, write an equation of the line tangent to the graph of g at the point where x equals 0. Okay, so if I'm talking about the equation of the line tangent to the graph of g, that means I want to know when g prime of 0 equals something, so that's going to be my slope. So g prime of 0. It looks like I need to plug into my function because I was not given that. So I'm going to have e to the negative 2 times 0 times 3 f of 0 plus 2 f prime of 0. So that's e to the 0, which is 1. So that this all is 1. It doesn't matter. Okay, so now I have 3 times f of 0. So that's 3 times f of 0 is 2, plus 2, f prime of 0 is negative 3. So I get 6 minus 6, so I get 0. Okay, this means that I have a horizontal line for my line tangent to the graph of g. All right, I am given that g of 0 equals 4, so that means that my point is 0, 4. My slope was 0, because this was my slope. So I get y minus 4 equals 0 times x minus 0. In other words, that one is pretty easy to simplify. Since it was a horizontal line, you know it's y equals 4. Okay, that would be your solution. All right, and then part D, show that g double prime is equal to e to the negative 2x times negative 6 f of x minus f prime of x plus 2 f double prime of x. Does g have a local maximum at x equals 0? Justify. Okay, so the AP exam will do this a lot where it says show that this is true. So they kind of want to give you some points even if you can't actually get that derivative. So even if you couldn't verify that this was true, you could go on to the second part of the problem. So that's nice about these problems. Okay, so D. Okay, so we had our g prime up here. So we're going to take the derivative. So I'm going to use the product rule and the chain rule with my power here. All right, so I have g double prime of x equals, the first was e to the negative 2x times the derivative of the second part. So the inside part's derivative is 3 times f prime of x plus 2 times f double prime of x. Remember, you can just pull the number out front. That's a plus sign. Okay, plus the derivative of the first thing is e to the negative 2x times negative 2, and then the second thing stays the same. So 3f of x plus 2f prime of x. Simplify. The nice thing about these problems with e is you can always pull out what they have in common, so e to the negative 2x. And I combine my like terms, so I get 3f prime of x plus 2f double prime of x minus, I need to distribute my negative 2, so minus 6f of x minus 4f prime of x. So like I said, combine your like terms. So I get e to the negative 2x. I have 3 minus 4, both f primes, so I'm going to have negative f prime of x. That's going to be right there. I have one thing with f of x, that's the negative 6 f of x. So minus 1 f prime of x plus 2 f double prime of x. Okay, I wrote it in the exact same order that they wrote for me to verify. Okay, so it's that. Okay, let's go to the next page to have a little bit more room. So does g have a local maximum at x equals 0? Justify your answer. So if I was going to find if something has a local max, again, you can think of g prime. So the chart. In order for it to have a local max, you need to go increasing and then decreasing. And at that particular point, you need your g prime to equal 0. Okay, so looking at g prime of x, so here, let me write down my equation again. So g prime of x was e to the negative 2x, 3f of x, plus 2f prime of x. That's g prime of x. G double prime of x, we just verified. So you already have all this written down on yours. Okay. Now when I'm thinking of this and I'm like, why did they give me information about the second derivative and I'm just asked to find the local max? Okay, if you guys remember in this chapter we learned something called the second derivative test. So it said if I'm going to have a local max, I need to be concave down and I need for g prime of whatever x value we're talking about, so at 0, to equal 0. So that means g double prime of 0 has to be less than 0. Okay, so let's see. Plug in 0. This is g double prime of 0. This first part's 1. I have negative 6 times f of 0. Didn't we already do this? Oh, no, we did it for g prime. So negative 6 times f of 0 was 2. Minus f prime of 0 is negative 3. Plus 2, f double prime of 0 is 0. So I get negative 12 plus 3, so I get negative 9. So it's concave down. And I'm going to write g, so I'm very specific. I'm talking about what function is concave down. And then I also know that g prime of 0, we had to find that already. G prime of 0 was 0. So since I know that g prime of 0 is 0, and it's concave down at 0, by the second derivative test, I can say that there is a max. So I'm going to say there is a local max at x equals 0 by the second derivative test. And that's it.